Assalamualaikum dan selamat pagi. So pagi ini saya akan teruskan dengan chapter 3 bagi Cloud Upper Age, khusus Cloud Computing Upper Age. Okey, kita sama TVET bagi tahun 2024. Okey, tajuk Networking Cloud Services. Okey, sebelum ni dalam chapter 2 pelajar sudah didedahkan dengan IMS, iaitu Image Management Service, ECS, Elastic Cloud Server, AS Auto Scaling. Pelajar juga dah belajar berkenaan CCE, Cloud Container Engine, EVS, Elastic Volume Service dan AZ, Availability Zone. So hari ni kita teruskan untuk chapter 3. Okey, saya bahagikan kepada dua video. Okey, so video pertama saya akan menceritakan berkenaan dengan Virtual Private Cloud VPC, Elastic IP, EIP dan Elastic Load Balance ELB. Okey, untuk support untuk modeling tu boleh abaikan. Okey, boleh rujuk kepada login. This one nanti tunggu pada instructor untuk beri credential. Buat masa ni belum ada lagi. Okey, support dokumen untuk Alpha H boleh rujuk di sini dokumen. Okey, so untuk this one tajuk Networking Cloud Services. Okey, dia kita pergi kepada pengenalan dahulu. Okay, so network resources are essential to the development of the ICT infrastructure. With network resources, device and system can communicate with each other so that enterprise can provide better service to their end user. Okay, so this chapter basically describe the network services provided by Cloud Alpha H. Okay, next objective for this video is for you to able to understand one network service and the applications of different service, understand the concept and usage of VPC, okay, understand the concept and usage of EIP, understand the concept of VPN and net gateway. Okay. Alright, so what is a network service? It's a network system that connects multiple computers or other devices together so that they can communicate and share resources with each other. Okay, so network can be different types such as local area network, wide area network, or either internet. Okay, so Cloud Alpha H provide various network active services to help build secure and scalable network on the cloud. Cloud connect an on-premises network in high speed and reliable way and connect on-premise data center to the internet. So this is the example of how the connection can be done. So let's see, this is a on-premise data center, or this is the internet. Okay, connected using ELP, net gateway, and ELP, which is they have a VPC and they have a subnet lah. Okay, based on the region, or maybe it's a VPC through private channel, VPN. Okay, Alpha H can do that. Okay, next, so the content, so we have like 5 content here. Okay, what is VPC? Okay, basically you need to know that VPC is a virtual private cloud service in a Cloud Alpha H, which enable you to provision logically isolated, configurable and manageable virtual network for cloud server, cloud container and cloud database. Okay, and it improve cloud service security and simplifying network deployment. So as you can see, alright, like this tunneling technology, we have VPC 1 and we have VPC 2. Okay, so in each VPC have ECS. So ECS, as you know, is Elastic Cloud Server. They have 3 Elastic Cloud Server. VPC 2 also have 3 Elastic Cloud Server. Okay, so in this diagram you can see, okay, it's connected, but tunneling technology can go to each VPC 1 and VPC 2, but VPC 1 and 2 cannot communicate with each other lah, but they can use it a tunnel. Okay, so we can provision that each VPC. Okay. Okay, next, so advantage of VPC. Okay, they have 4 main advantage. The first one is seamless interconnectivity. Okay, Second one is secure and reliable. Third one is flexible configuration, and the fourth one is high speed access. So what is the meaning of seamless connectivity? It means that we can connect multiple methods to the internet using the cloud upper edge, and a VPC peering connection enables two VPC to communicate with each other using private IP address. So it's much more confidential, the transaction in the data lah. Okay, secure and reliable is 100% logical isolation within each other. Okay, and comprehensive security. Okay, what is a high speed? It can have dynamic BGP access to multiple carrier, okay, to the telco. Can and also have automatic failover in real time. It support this one. Okay, and for flexible configuration, user can define their own network, and ECS, which is Elastic Cloud Server, can be deployed across AZ. AZ means availability zone. Okay, you can create your ECS and create your AZ, and then you able to deploy. Okay, so next, so this is example of VPC architecture. As you can see here, we have VPC 1 here, this rectangle, this square, and we have VPC 2, this square, connected with VPC peering connection, and each VPC they have its own internet. Okay, internet gateway different. For this one connected with net gateway and EIP. As you know, EIP is elastic IP. Okay, then for each router in the VPC 1 and 2, they have a connection, like example, VPC 1 through VPN to the IDC, which is Internet Data Center, and VPC 2 might be they have direct connect using the direct connect method. Okay, two different connection, but it can go through the IDC. Okay, then it can talk with each other. Okay, so next, so what is in the VPC component? So each VPC consists of private CIDR block, route tables, and at least one subnet. So as you can see here, this is one VPC in the rectangle, this one. Okay, so this VPC, they have a private IP address. Okay, 192.168.0.0/16, and they have a routing table for two subnet. As you can see, for first subnet is .1/24, 1.0/24. For subnet 2 is 2.0/24, whereas in subnet 1 they have two security group. Okay, group A, group B. Okay, which is in group A only have ECS only. ECS mean Elastic Cloud Server. But for group B security group, they have ECS and RDS. Okay, two. Okay, different item. And let's say in subnet B, subnet 2, okay, this is subnet 1, they have only one security, which is group A, and it have ECS and BMS. So BMS is referring to bare metal server. Okay, so you can see differ in one VPC, they can have consist, okay, at least one subnet lah. So this one we have two subnet and different security group, okay, for each of the subnet. Alright, so the concept of VPC is have subnet, have security group, have IP address group, have elastic NIC, network interface card, elastic have network SCL, okay, access control list, they have their own routing table, have VPC peering connection, and have virtual IP address, and have the most important thing is EIP. EIP stands for elastic IPs. For this is the connection to the internet, as you can see here. Okay, connection to the internet. Okay, for use of EIP. Okay, next, what is subnet? Okay, subnet is a unique CIDR block, a range of IP address in your VPC. All resources in VPC must be deployed on subnet. Okay, once a subnet has been created, its CIDR block cannot be modified. So, as you can see here, alright, example here, we have one VPC 192.168.0. It's the same one like that one, but we use 0.0. Okay, so the subnet 1 is 0.0/24, while subnet 2 is 1.0/24. But inside the subnet 1, okay, you can configure for ECS, CCE, Okay, CCE is stand for Cloud Container Engine, and RDS. Okay, so for subnet 2, okay, configure for BMS, bare metal server, CCI, and also DDS. Okay. Okay, as per my checking, okay, CCE stand for Cloud Container Engine, RDS stand for Relational Database Service, KCCI is Cloud Container Interface, and DDS is Document Database Service. Okay, so it can be deployed on different subnet with different services. Okay, so once a subnet has been created, ECI cannot be modified. Okay. Okay, so what is Elastic IP? It's a service enable your cloud resources to communicate with internet using static public IP address and scalable bandwidth. Okay, EIP can be bound to or unbound from, okay, ECS, BMS, virtual IP address, net gateway, or load balancer. So only these 5 services that can be bound with EIP. Okay. Alright, so as you can see here, for the EIP, they have ECS, net gateway, load balancer, okay? Okay, actually this one we can configure also for BMS, okay, if we want. Alright, so route table. So what is a route table? So as networking, okay, you must know that route table contains a set of routes that are used to determine where network traffic from subnet and VPC is directed. So you want to know which is the source and the destination. So it's keep the information in the route table. So each subnet must be associated with route table. So if let's say you have 2 subnet, each of the 2 subnet must be associated with route table. Information must be put into the route table. So you can associate a subnet with one route table at all time, but you can also associate multiple subnet with same route table. Okay, it should be no problem lah. So like this one, example the same one, okay, 198.0.0/216. Okay, let's say we have 2 subnet. No, like this one is 3 subnet. Okay, subnet 1 is 0.0/24, subnet 2 is 1.0/24, and subnet 3 is 2.0.24. And let's say for each of the subnet, we have configure ECS, okay, Elastic Cloud Server. For each subnet, we have 3 ECS. This one, subnet 2 also E3 ECS, and subnet 3 also 3 ECS. So the route table, let's say, because the subnet 1 only have one subnet, so routing table can be configured for that particular subnet only. Then let's say in this VPC, we have 2 subnet configured. For each subnet have 3 different ECS. Okay, so we can have the both subnet 2 and subnet 3 information in the same route table. Should be no problem. We can do that. Okay. Alright. So security group. So a security group is a collection of access control rules for ECS. So when you configure ECS, you need to configure the ACL. Okay, that have the same security requirement, are mutually trusted within a VPC. This is for the security part of ECS. After you create a security group, you can create different access rules for the security group, and the rules will apply to any ACS that the security group contain. Okay, let's example this one VPC, this one VPC. Okay, then let's say you have create ECS. Okay, so you have 3 with ECS. So let's say in between one is S1 and 2, you want to have mutual access. So you can create what we call it control access controllers for between these 2 ECS. Okay, then we have a mutual access. But let's say between ECS 2 and 3, you don't want it to have multiple mutual access. So you can deny the all inbound connection between ECS 3 to ECS 1. But you may allow all outbound for ECS 2 to ECS 3. Okay, we can do this configuration inside the access control rules of ECS. Okay, in using the security group. Okay, let's see for the VPC peering connection. So a VPC peering connection is a network connection between two VPC in the same region. It enables you to route traffic between them using private IP addresses. You can create a VPC peering connection between your own VPC or between your VPC and a VPC of another account within the same region. Okay, however, you cannot create a VPC peering connection between VPC in different regions. So you want to make a VPC pairing connection only between the same region. Between different region, no, you cannot configure that. Okay, so let's say we have two region. Okay, so the region part, this one you learn in the chapter 2 previously. So let's say we have region A and region, but in a VPC A, region A, and VPC B, we have a region A. So this is a different region, but might be in different VPC. Okay, so each VPC, for VPC A, you configure ECS. Okay, and you configure ACS1 and ACS2. But inside the VPC B, which is a private connection, you just configure RDS, which is Relational Database Service, and RDS2. Okay, then you want to have a VPC pairing connection between A, region VPC A, in region A, then VPC B in region B. Can this one be done? Yes. Why? Because this is between the same region. Even though it's a different VPC, but it's in the same region, then we can do that, the peering. So we can configure the peering. So this all VPC A will have their own security group, and for VPC B also they have a own security group, and we can make it talk with each other. Okay, but if let's say it's a different region, let's say this one is region A, this one is region B, then we cannot configure the peering. Okay. Okay, next, what is network SCL? Okay, it's an optional layer of security for your subnet. After you associate one or more subnet with a network SCL, you can control traffic and out of the subnet. So let's say this is a VPC, and we have a subnet 1 and subnet 2, then we have configured the security group 1 and group 2. Okay, for connection for subnet 1 and 2 to the router, okay, let's say you want is to connect to the others internet. Okay, we able to configure extra layer of security, okay, using the network SCL for each subnet 1 and subnet 2. We can have a different SCL for different subnet, or we want to have the same SCL for different subnet. Can also be done. Okay, so next, what is virtual IP address? Okay, it can be shared among multiple ECS, which is among multiple Elastic Cloud server. Okay, so SES can have both private and virtual IP address. So you must understand lah, ECS you can have both IP public and private, and you can access the ECS through either IP address. So let's say you are outside of the internet and you want to configure your ECS from the outside of the internet, then you can configure the virtual IP lah. Okay, so virtual IP address have the same network access capability as a private IP address. Virtual IP address are used for high availability as they make active standby ECS switch over possible. So let's say as you see this one, example, so virtual IP address is 10.10.1.1. Okay, so this one, let's say this is the private, this one is the virtual one. So this is the ECS, okay, first one, and this is the SCS, the second one. Okay, this one with the IP is 10.10.1.11, and this is 10.10.1.12. And we have between each ECS, they have the keep alive message. So let's say if anything happen, then we can use the .10, okay, to connect to each one. Okay, so let's say this one, so we can have an active and standby mode like this one. So as you can see here, the server, okay, that is the server 1 ECS, the server 2 ECS.1.14, this 1.13. So connection with the LVS node, okay, this is the active one, 1.11, and this one is standby mode, 1.12. So they have keep every life between each other, and then this one connected via virtual IP address .10. Okay, alright, so Next is elastic network interface. What is elastic network interface? It's a virtual network card. Okay, so in a cloud server, we need to have a extra network card to configure IP address. So we use to we rename this one as elastic NIC. Okay, a virtual. You can create and configure network interface and attach them to your instances, which is either ECS, Elastic Cloud Server, or BMS, Bare Metal Server, to obtain flexible and highly available network configuration. So a primary network interface is created together with an instance by default, which cannot be detached from each instance. So you cannot detach it from the instance. When you create the instance, okay, so the primary one will by default have instance with the instance lah. Okay, primary network interface. But you able to create extension network interface. So this one you can attach to the instance, or might be you want to detach them from the instance. Okay, the number of extension network interface you can attach to ECS varies by ECS flavor. Okay, what ECS that you use? Okay, alright. So this is example of IP address group. Okay, collection of IP address that you might want to associate with security group or network SCL to simplify IP address configuration and management. So let's say this one example, we have IP address group for IP group A. Okay, so we have the range of IP and the single IP address. So single IP address is usually we use for the interface. Okay, /32. Okay, then let's say this one we have a security group, okay, A, and we have a network access group for firewall. Okay, for might be region A. So we can put inside the collection of IP address this one lah. Okay, so how to do the VPC configuration process happen? Okay, first we need to start with create a VPC. Okay, the created VPC have a default subnet. By creating the VPC, by default they have a default subnet. Okay, and optionally you can create another subnet for VPC. Let's say you want to add a subnet for that VPC. Let's say you want to add another subnet, different two new subnet in the VPC. You can do that. Okay, so once you create the VPC, then you need to create a security group. Okay, so for the security group, you need to add a security group rule. By the way, this is optional lah. So add a security group. Okay, then the process of the VPC is finished. Okay, so go to the subnet, VPC subnet. This is how you configure. So each VPC comes with a default subnet. If the default subnet cannot meet your requirement, you can create a new one. Okay, so the subnet is configured with DHCP by default. So when ECS in this subnet start, the ECS automatically obtain an IP address using DHCP. So by default, you create VPC, then you have a default subnet, and by default the default subnet is configured by DHCP. Okay, so when you start, it obtain the IP address using DHCP automatically. So an AZ, which is availability zone, is a physical location where resources use independent power supplies and network within a given region. So you need to configure all this lah when you configure the VPC. So what is the security group? Then you need to create the security group. Okay, so it by default it automatically come. Okay, your account for VPC from this one, you create a security group. Okay, it's come with default security group. So you can add inbound or outbound rule to the default security group, or might be you want to create a new security group. Okay. Okay, so inbound rules control incoming traffic to ECS in the security group. If outbound rules control outgoing traffic from ECS in the security group. Okay, so default security group rules also we have that one. Okay, so the difference between VPC vs traditional IDC. Okay, so do you know what it is IDC? Internet Data Center. Okay, so first one in terms of we have like four. Okay, four different between traditional IDC and VPC cloud, right? Okay, in terms of deployment cycle, in terms of total cost, in terms of flexibility, and in terms of security. So as you can see, for in terms of deployment cycle, okay, virtual private cloud, you do not need to perform complex engineering deployment. No need. In terms of hardware, you no need to think about it. Okay, you do not need to think about the engineering planning and cabling, also all the thing. Okay, you can determine your network subnet route on cloud or based on service requirement. Okay, what you need to have, you just not need to know what you have, what is the requirement for the topology for the cloud. Okay, then you just configure it. No need to think about the hardware part, the cabling part. So, but for the traditional IDC, you need to set up network from scratch, then you need to perform tests. So, this entire process will take a lot of time, and it requires professional technical support. So, it might be, so when it takes a long time and it requires professional personnel, it will be much more expensive, okay, compared to the VPC. So in terms of total cost, you can see is provide flexible billing mode for network services. So you can select whichever one best fit your business. So based on your business need. So there are no upfront costs and network O&M costs, reducing the cost of ownership. Okay, total cost of ownership, TCO. Okay, but for traditional IDC, you need to invest in the equipment room, power supply, construction, hardware material. Then you need, okay, professional O&M need is operation and maintenance team, okay, to ensure network security. Okay, so all this will might be increase the asset, okay, in the company and then business requirement lah. Okay, alright. So in terms of flexibility, okay, Cloud Upper Edge provide variety of network service for you to choose. If you need more network resources, for instance, you need more bandwidth, then you can expand resource on the fly. But in terms of IDC, in terms of flexibility, you need to strictly comply with network plan. Okay, to complete the service deployment. You cannot simply add your resource to add more resources. Like, you need to have approval for the service, then you need to have justification for the changes before we can try adjust the network. Okay, so it takes time. Okay, that is an IDC. So in terms of security, VPC are logically isolated from each other. So you can use security feature such as network SCN and security group, and even security services like AAD to protect your cloud resources. But for IDC, okay, the network is insecure and difficult to maintain. You need, like the first one that I tell, so you need a professional technical personnel to ensure network security. So it might be costly. Okay, costly. Okay, next you go to the application scenario. So let's say we have dedicated network on cloud. So each VPC represents a private network and is logically isolated from other VPC. So as you can see here, okay, we have VPC 1, VPC 2, logically is different, okay, isolated. Okay, so you can deploy your service system in private network of cloud, and you can have multiple service system. For example, production system and test system separately, and you can keep them isolated by deploying them into different VPC. So each of the VPC will have their own security group with their own subnet. Let's say this one you have subnet 1, subnet 2, they have their own security group. You have a network address, network SCL connected to router. We might have their own EIP to connect to internet. Okay, so it isolated with each other. Okay, alright. So web application website. Okay, let's say you need to have web application website hosting. So you can host web application and website in a VPC and use the VPC as a regular network with EIP or net at gateway. You can connect ECS running your web application to the internet. So let's say you need a business, okay, need to have a website hosting, then you can use the cloud upper edge, and you can then use load balancer provided by ELB, so ELB, elastic load balance, to evenly distribute traffic across multiple ECS. Okay, so let's say this example, we have one VPC. So in the VPC, we have two different zone, which is zone 1 and zone 2. Which is in zone 1, we have 3 ECS. Okay, ECS 1, 2, 3, and in SG2, we have also 3 ECS, but with different subnet. So this is 1.0 for subnet 1, and this one is 2.0 for subnet 2. But both of the subnet will be connected to the router, the same router. Before it go to the internet, it pass to the network gateway for the security part, and it have the EIP, okay, to connect to internet, and it have ELB, okay, elastic load balance, to balance between all these two. Okay, alright. So now to go to the what is go to, this is all about the VPC. Okay, later I will start with the elastic IP server. Okay, bye bye for now.